The Milky Way Galaxy, our cosmic home, is a vast and mysterious place filled with wonders that challenge our understanding of the universe. But how much do we really know about it? Have you ever wondered what secrets lie within its spiral arms or how it came to be? From its staggering size to the intriguing black hole at its center, the Milky Way is full of surprises. Join us as we explore 10 amazing facts about the Milky Way Galaxy, unraveling the mysteries of our galactic neighborhood like never before. The Milky Way's enormous size. The Milky Way Galaxy is absolutely colossal. Spanning about 100,000 light-years across, it would take a beam of light, traveling at a staggering 186,282 miles per second, 100,000 years to journey from one end of our galaxy to the other. Our solar system is located roughly 27,000 light-years from the galactic center, nestled within one of the Milky Way's spiral arms known as the Orion Arm. Even though this might seem like a central position, we're actually far from the galaxy's core. Within this immense structure, the Milky Way contains between 100 to 400 billion stars, each potentially hosting its own system of planets. Despite its massive size, the Milky Way is just one of billions of galaxies in the universe, many of which are even larger. Yet it's the galaxy we call home, and understanding its scale helps put into perspective just how vast our universe truly is. The sheer enormity of the Milky Way is both humbling and awe-inspiring, reminding us of our small but significant place within it. Our galaxy is a barred spiral. The Milky Way is classified as a barred spiral galaxy, a type of galaxy characterized by its spiral structure and a central bar-shaped region of stars. Unlike traditional spiral galaxies, which have arms that wind directly out from a central bulge, barred spirals feature a bar of stars running through the center, with the spiral arms extending outward from the ends of the bar. This bar structure is thought to act as a kind of stellar conveyor belt, funneling gas and stars into the galactic core, which can help fuel star formation. The Milky Way's spiral arms are not just pretty patterns, they are regions of intense star formation. Our solar system is located in the Orion Arm, a minor arm of the Milky Way. The galaxy's major arms, like the Perseus Arm and the Sagittarius Arm, are packed with young, hot stars, massive molecular clouds, and regions known as nebulae, where new stars are born. The barred spiral structure is a defining feature of the Milky Way, influencing everything from its overall dynamics to the distribution of stars and gas within it. The mysterious dark matter. One of the most puzzling aspects of the Milky Way is the presence of dark matter, a mysterious substance that does not emit, absorb, or reflect light, making it invisible to our current instruments. Despite being unseen, dark matter is believed to make up about 85% of the total mass of the Milky Way. Its existence is inferred from its gravitational effects, particularly on the galaxy's rotation. Without dark matter, the stars in the outer regions of the Milky Way would not move as quickly as they do. Scientists believe that dark matter forms a halo around the Milky Way, extending well beyond the visible parts of the galaxy. This dark matter halo plays a crucial role in the formation and evolution of the galaxy, helping to hold it together. Understanding dark matter is one of the greatest challenges in modern astrophysics, and the Milky Way provides a valuable laboratory for studying this enigmatic substance. As we learn more about dark matter, we continue to uncover the deeper mysteries of our galaxy and the universe itself. The galactic center and its supermassive black hole. At the heart of the Milky Way lies a region of immense intrigue, the galactic center. This area, located in the constellation Sagittarius, is densely packed with stars and home to a supermassive black hole known as Sagittarius A*. This black hole has a mass of about 4 million times that of our Sun and exerts a powerful gravitational pull on everything nearby. Despite its enormous mass, Sagittarius A* is surprisingly small, with a radius of just 17 times the distance from the Earth to the Sun. The presence of this supermassive black hole has profound effects on the surrounding area, influencing the motion of stars and gas clouds in its vicinity. While black holes are often depicted as cosmic vacuum cleaners, Sagittarius A* is relatively quiet, only occasionally flaring up as it consumes matter that ventures too close. The discovery and study of Sagittarius A* have been pivotal in our understanding of black holes, offering a unique glimpse into our galaxy's core dynamics. The galactic center remains one of the most fascinating and mysterious regions of the Milky Way. The Milky Way is on a collision course. One of the most dramatic events in the Milky Way's future is its inevitable collision with the Andromeda Galaxy. Andromeda, our closest galactic neighbor, is currently hurtling toward the Milky Way at a speed of about 250,000 miles per hour. Although this might sound alarming, there's no need to panic. This galactic collision is expected to occur in about 4.5 billion years. When these two spiral galaxies collide, they will merge to form a new, larger galaxy, which some scientists have already named Milkomeda. Interestingly, despite the massive scale of this collision, individual stars within the galaxies are unlikely to collide due to the vast distances between them. Instead, the interaction will dramatically reshape both galaxies, triggering bursts of star formation and altering the structure of the combined galaxy. The Milky Way-Andromeda collision is a reminder that our galaxy is not a static entity, but is constantly evolving and interacting with its cosmic environment. This future cosmic event is one of the most anticipated phenomena in astronomy, offering insights into the life cycles of galaxies. The Milky Way's satellite galaxies. The Milky Way is not alone in its journey through the cosmos. It is accompanied by a group of smaller satellite galaxies that orbit around it. The most famous of these are the large and small Magellanic Clouds, which are visible from the southern hemisphere. These dwarf galaxies are irregular in shape and are thought to have been distorted by the Milky Way's gravitational pull. They are also rich in gas, making them active sites of star formation. In addition to the Magellanic Clouds, more than 50 known dwarf galaxies are orbiting the Milky Way, each contributing to our understanding of galaxy formation and evolution. Some of these satellites, like the Sagittarius dwarf spheroidal galaxy, are slowly being torn apart and absorbed by the Milky Way in a process known as galactic cannibalism. The interaction between the Milky Way and its satellite galaxies plays a crucial role in shaping the structure of our galaxy, influencing everything from its halo to the distribution of dark matter.
The age of the Milky Way.
Determining the age of the Milky Way is no easy task, but scientists estimate that our galaxy is about 13.6 billion years old, only slightly younger than the universe itself, which is around 13.8 billion years old. The Milky Way began forming shortly after the Big Bang, starting as small, dense regions of gas and dark matter that gradually merged to form larger structures. Over billions of years, these early structures evolved into the spiral galaxy we see today. One of the ways astronomers estimate the age of the Milky Way is by studying its oldest stars, particularly those in the galactic halo. These ancient stars, known as population 2 stars, have low metallicity, indicating that they formed early in the galaxy's history before many elements heavier than hydrogen and helium had been created. By understanding the age and formation history of the Milky Way, scientists can gain insights into the processes that shape not only our galaxy but also the broader universe. The Milky Way's stellar population. The Milky Way is home to a staggering number of stars, between 100 and 400 billion depending on estimates. These stars come in a wide variety of types, from cool red dwarfs to massive blue giants and everything in between. Most of these stars are located within the galaxy's disk, where they are organized into spiral arms. The Sun, a relatively ordinary G-type star, is just one of these billions, orbiting the galactic center at a speed of about 514,000 miles per hour. The stars in the Milky Way are not evenly distributed. They are organized into distinct populations. The disk of the galaxy contains younger stars, many of which are part of star-forming regions like the Orion Nebula. The central bulge and halo contain older stars, some of which are among the oldest in the galaxy. The variety of stars in the Milky Way provides a rich tapestry for astronomers to study, helping them to understand everything from stellar evolution to the history of the galaxy itself. The Milky Way's rotation. The Milky Way is in constant motion, rotating around its center at an average speed of 130 miles per second. This rotation is not uniform. Stars closer to the center of the galaxy orbit faster than those further out, a phenomenon first observed by astronomer Vera Rubin. This discovery led to the realization that dark matter must exist. as the observed rotation speeds could not be explained by the visible mass of the galaxy alone. The rotation of the Milky Way also means that our solar system is in constant motion, taking about 230 million years to complete one orbit around the galactic center. This period, known as a cosmic year or galactic year, has seen the Earth undergo dramatic changes, from the rise and fall of dinosaurs to the evolution of humans. The Milky Way's rotation is a fundamental aspect of its structure, influencing everything from the formation of spiral arms to the dynamics of star formation within the galaxy. The Milky Way is part of the local group. The Milky Way is not an isolated galaxy, it is part of a larger cosmic neighborhood known as the local group. This collection of galaxies includes about 54 members, with the Milky Way, Andromeda, and the Triangulum Galaxy being the largest. The local group spans about 10 million light-years across and is part of an even larger structure known as the Virgo supercluster. Within this supercluster, the local group is just one of many groups of galaxies, all gravitationally bound to one another. The interactions between galaxies in the local group, including the future collision between the Milky Way and Andromeda, play a crucial role in shaping the evolution of its members. The local group also offers a unique opportunity for astronomers to study the dynamics of galaxies and their interactions in relative proximity. Understanding the Milky Way's place in the local group helps us to grasp our galaxy's role in the broader cosmic web, connecting us to the vast structures that define the universe. The Milky Way Galaxy is a cosmic marvel, filled with mysteries and wonders that continue to captivate astronomers and space enthusiasts alike. From its enormous size and complex structure to the enigmatic dark matter that holds it together, the Milky Way offers endless opportunities for exploration and discovery. As we continue to study our galaxy, we uncover more about the universe and our place within it. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us.